The key to understanding precipitation reactions is that understanding that insoluble compounds form the precipitate. Precipitate in chemistry is the same as an insoluble compound that forms. Precipitation reactions always contain two solutions with soluble compounds that combine, and at least one insoluble compound forms. So let's look at the example we looked at previously. Here we have potassium iodide, and it is AQ, which means that it is dissolved in water. It's a solution, and since it is an ionic compound, it is a strong electrolyte which dissociates. And then the other reactant is lead 2 nitrate, which, since it is an ionic compound, it also dissociates. So both of these are soluble, and that's indicated by the AQ. That means it's dissolved in water. When these two combine, we basically get a switching of ions. That's why this is also known as a double displacement reaction. The potassium is with the iodide in the reactant side. But on the product side, the potassium is with the nitrate. The lead is with the nitrate on the reactant side, but on the product side, it's with the iodide. So we've basically had a switching of ions, and that's basically how precipitation reactions form. This cation combines with this anion, and this cation combines with this anion. And then if one of them forms an insoluble compound, then that's known as precipitate, and that's how precipitation reactions occur. So to be able to identify if a precipitation reaction is occurring, first there have to be two ionic or strong electrolytes, and we'll get into the definition of other strong electrolytes. There have to be two ionic or strong electrolytes that are reacting. These ionic compounds, or the strong electrolytes, switch ions, and at least one of them is going to form an insoluble compound, which is signified with this S for solid. So would this second equation be a precipitation reaction? First, we want to identify if both of our reactants are soluble, and we see that they are both AQ. The next question we want to ask ourselves, are they both strong electrolytes? Since they are ionic compounds, since they both have metals in them, sodium and copper, then yes, they are strong electrolytes. So we have two strong electrolytes. They are AQ. Do they switch their ions? And when we look from the left to the right, or from the reactant to the product side, we see that they do. Sodium has the carbonate anion with it on the reactant side. But on the product side, sodium has chloride with it. And let's go ahead and balance this equation while we're at it. And then if we look at copper on the reactant side, it has chloride as its anion. But on the product side, copper has carbonate as its anion. So our cations have switched their anions. We have two strong electrolytes which are soluble on the reactant side, or the left-hand side, and then one compound that is insoluble on the product side. So that's how you identify whether a precipitation reaction has occurred.